All right. Now the good news is the last one went a little longer, but this one's going to go shorter because we just got 5 quick questions. We have a new concept, and I'll say this time it's our first, what I'm going to refer to as algorithm. And it's this magic process called synthetic division that saves us time, 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 and time. Now we're going to just jump right in and kind of learn by doing examples and learn the algorithm of synthetic division. So it turns out that there's a way to divide polynomials. Now you've seen multiplying polynomials because after all, we've done, x minus 2 times x squared minus 3x plus 5. And we know how to do that. We know how to distribute, 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 combine like terms, but we haven't gone the other way. We haven't divided things out necessarily. We've factored, which is technically division. You're breaking things down into their components, but we've really only factored when we like knew the answer. So what do we do in cases like this? Well, someone came up with a process called synthetic division. Now watch what happens. I guess because it's synthetic division, we write an upside down division symbol. Interesting. What do we then write? And leave some vertical space here, kind of copy my spacing. We write what's called, again, the coefficients of the thing being divided. From there, we are then going to write the thing we're dividing by, not the algebra though, right? Just like we copied only the coefficients, we're going to copy the root of this. And if you catch that wording, it means we're going to flip that and grab +1 because that's what makes this thing equal 0. Okay, so we have our thing being divided. We have our divisor, again, flipped as a root. What on earth is this algorithm? What are we going to do? Well, first thing we always do, you might want to get in the habit of doing this, draw an arrow and drop that first number down, which should feel a little familiar to division. We would drop things down as we would go through. Here's where things get different though. It's drop down and then multiply across. So 1 times 3 is 3. What do I do now? I drop down. But now there's not a blank here. There's a 1 and a 3. So when those drop down, those become 4. What do I do now? I multiply across. 1 times 4 is 4. What do I do now? I drop down and I get 0. And this is special because this was our last one, so I always like to put a box around this. Now, what on earth did we just do? Well, it turns out that we can write it like this. It means that this is equal to, now watch this, if 3, 1, and -4 corresponded to an x squared, an x, and a number, then catch this, from your remainder, here's your number, and here's your x. So that is what we call your quotient. And what's your remainder? Your remainder in this case is 0, which I guess means there is none. You don't have to write it, but sometimes people will write it like this. Just like old school division, like if you had, I don't know, 15 divided by 4, you would say that that's 3 quotient and 3/4 remainder over what I was dividing by. Mixed numbers, that's where those come from. Here's your quotient, the 3 correspondingly, and here my remainder was 0 over what I was dividing by. So same idea there, you might see it written like that. Now, more so, here's the important thing, and then we're really going to start flying, is that what I just figured out is that x equals 1 is a root since the remainder was 0. Now, what's another way of saying that for this example? It means this quadratic, this is a quadratic, I mean, it is a polynomial, but right now the highest degree is 2, so we could call it a quadratic. This quadratic evidently could have been factored by grouping, and I just figured out that after I would do my by grouping, Because my remainder was 0, I know for a fact that this breaks down to 3x plus 4, x minus 1, and you should FOIL that back out and see that you get back to the original. That's pretty cool because essentially we found a way to not need to know factoring and still get a factorable result. The one last thing to pay attention to is, again, the way that these numbers from the original were the coefficients, and your result on the bottom are new coefficients to a new answer. And so from the remainder, you go number, x, x squared if there was 3 or 4, and so on and so forth. So just be aware of that. And if you're still a little iffy on this whole process, well, that's why we've got 4 other examples, and there's not going to be as much to say with all these. So for number 2, we're going to write our upside down division. And again, maybe take a second and see if you could fill in the numbers and fill in this number. I'm going to go ahead and start. It'll go 5, -2, 3, and -2. And because this is x plus 2, what I'm going to put up here is its root -2. All right. Hopefully, maybe you already memorized the pattern, but if not, here we go. First number always gets dropped by itself. Then I multiply. So multiply outside, so to speak, or again, across as I kind of call it. That'd be -10. And now I drop down, but I have to combine these, and that makes -12. Then I multiply. That makes +24. Then I combine. That makes 27. Then I multiply. Uh-oh. This makes -54, and I combine, that makes -56. Okay, so then what is my quotient? Sorry, this was the last one. Put it in a box. My quotient is this, the thing I got from division, and here's my remainder. Now, how do I write it? Well, like I said before, even though this remainder isn't 0, it's still my remainder. So from my remainder, this would be my number. This would get an x. This would get a squared. So I'm left with 5x squared minus 12x plus 27. And then I've got a remainder. It's -56 over what I was dividing by. Now, in other words, what is this thing? And sorry, I'm going to rewrite it like this now. What is this thing? Well, this is not a polynomial, and it also means this isn't actually a nice factor. Because this wasn't 0, I actually really can't do anything with this other than tell you that x plus 2 is not a factor. Or in other words, x equals -2 is not a root. That's really all you do with it. You can divide, you can write it as a quotient and remainder, but really, for us, all we care about is, well, wasn't a root. All right, the next one's going to go by even quicker, but there is one last careful thing to watch out for. Oops, that was a little too much. Here's the careful thing to watch out for. So far, if we look at our degrees, we went 2, 1, 0. We went 3, 2, 1, 0. Watch what happens this time. We go 5, so copy the coefficient, but then we go from 5 right to 3. What do I do about that gap? Fill it in with 0. If there was no power to the fourth, you're going to write 0 in for it, because after all, there were 0 powers to the fourth. Then I get my cubed, then I get my squared, then I get my x, then I get just 6 at the end. There's all my coefficients, but notice that I had to fill in the missing x to the fourth term with 0 as its coefficient, because it wasn't there. From there, 1 is the value I'm using, and this should go by pretty darn quick. So drop the 6, multiply, that's 6. Combine, well, because it's 0, it's 6 again. Multiply by 1, that's 6 over here. Combine, that's now 2. I know we're going fast, but again, it's just multiplying and adding. So multiplying, that's 2. Combining or adding, that's 7. Multiplying, thankfully it's 1. Or like I'm multiplying by 1, so again, it's just 7. And, excuse me. Combine, that's 4. and multiply, that's 4, and combine, that's 10. Once again, I found not a root, but careful, how do I write this? It's 10 is my remainder, and then there'd be a 4, a 7x, a 2x squared, a 6x cubed, and a 6x to the fourth. I'm not going to write that out. I'm just going to put this in a box and trust that you could translate that back to algebra like we did, I'll just say right similarly. But again, it's 4, 7x, 2x squared, 6x cubed, 6x to the fourth. They're all positive because no negatives showed up underneath there. All right, two more. We're so close. This time, catch the wording. It says use synthetic division to divide this and use the result to find all the zeros of f. Now, if you catch what I wrote in example 1 and example 2 off to the side, you'll see that they're actually telling you a lot of information here. What are they telling you? They're telling you use the result to find all the zeros. Now, what I told you is since it is a root and the remainder was 0, you could factor the rest of it and determine other roots. And also, what I told you before verbally was that if it's not a factor because it wasn't a root, because you didn't get 0, then you really can't do anything with this and you'd have to restart. So how do we put those two ideas together? In other words, when I do this synthetic division, I know, based on the phrasing of the question, I will get 0 at the end of my synthetic division because they're telling me from my result, I'll be able to continue. So I now know that when I'm done with this, I'm going to get 0. Great. A little self-assurance, or a little way to catch a mistake if I don't. There's the coefficients of the original 1x cubed, -2, -23, and 60. I'm going to use positive 4 because that's like the root value of this algebra. And here we go. Drop the first thing, then multiply. Combine your results and multiply. Combine your results, what is that, -15? And multiply. Combine your results. And as I said, no surprise, there's 0 at the end, which means I now have the translated algebra as -15, 2x, and an x squared. And what they're saying is they want me to find all the roots of f using the leftovers here. Now, in other words, are there factors of 15 that subtract to 2? Like I said, regular factoring isn't going away. There are. It's x plus 5, x minus 3. That's how you multiply to 15, but subtract to positive 2. You need a positive 5 and a negative 3 to subtract, or in other words, combine because they're both different, that's why it's subtraction, to positive 2, and that's how you multiply to negative 15. And so I now found, catch this argument, the last two roots of the 3, because don't forget that because this worked, 4 was a root as well. So my first root was given to me, and I found 2 more by factoring my result, or my quotient, so to speak, or my leftovers after synthetic division. Only do that when it works out to 0. If it doesn't work out to 0, there's no reason to touch anything from that quotient. But because it did, we're good to proceed. Now also, here's one fun fact. It should not be a coincidence to you that this problem started as x cubed, and we found 3 roots. Just food for thought. Let's keep going. Last example here, it says solve this given, or sorry, solve this given that 2 is a 0 of this, which sounds like repeated information, but in other words, they're saying, hey, please actually find all the values of x that would make this whole thing 0, given that 2 is a 0 of the same polynomial. It's a weird way of phrasing it, but in other words, hey, guess what we're going to do? We're going to use synthetic division. 1, 2, -5, -6. And I guess, sorry, I should clarify that. So why do they phrase it this way? Because this is an equation, and you technically don't do synthetic division on equations. You do equations on polynomials. And so they're trying to say that, hey, this equation had this polynomial. This polynomial has a 0, so that you can solve this equation. It's weird phrasing, but professors, what are you going to do? From there, let's solve. If 2 is a 0, careful, notice I'm not flipping this because this was not given to me in algebra either. They just told me 2 is a 0. 2 is a root. Hey, look, just like those numbers are roots. So I'm using that number directly because it didn't come from algebra that I had to flip. Drop the first number, multiply, combine, multiply, combine, multiply, combine. You should not be shocked that you got 0 because they told you 2 is a 0. By the way, that's what it means to be a 0. It means, or an x-intercept, it means when you did your synthetic division, you got 0 as your remainder. That's why it's referred to as a 0 in some senses. It's also referred to as a 0 because if you plug 2 in, you get 0 overall for your result. Okay, from there, again, these three numbers, to say this argument for the last time, just like these four numbers came from algebra in descending exponent order, so do these. But let's build up to it. From my remainder, this is the number, this gets an x, this gets x squared. Now I know what to write. And now I factor. Are there factors of 3 that add to 4? There sure are. 3 and 1. How do I multiply to 3 and add to 4? They're both positive. How do I solve each one of those? I flip their signs and I get -3 and -1. And don't forget that 2 was a root in the first place. So what you just discovered is you could plug -3 into this whole thing, and trust me, you will get 0. You can plug -1 into this whole thing, and trust me, you'll get 0. And you can plug 2, because it was a 0, and trust that you will get 0. Awesome. Well, that's it for this module, and hopefully this last section feels easier than the rest, and good luck, and let me know if you need anything. All right, bye.